Emmanuel, hi, good morning. So this is a machine, the cross belt machine. I will send you some information on it for your parts. A blocks, grinding blocks with abrasive and Scotch-Brite. This Scotch-Brite also has abrasive in the middle, and those are our more aggressive red ceramic blocks, which you can see here, the red color on the end. To really get a good rounding on your inside corner edges. There are two belts, one on the front that grinds right to left, one in the back that grinds left to right. Then there is the adjustment for the belt pressure here, and the adjustment for the material thickness. Your thinner gauges here, this white material is 1.5, this is 2.5. I ran some tests up front on a part that we had with the polyurethane coating to find a good setting. So we're going to run this at 5 feet a minute with the lighter settings, and then for the back side where we have this sharp edge on the corner from your corner notch, to make that nice and round and also give you more on the edge here, where from the shearing your burr on this part is on this side. So all we need to do is we need to close the door. You see we have a red light here right now. That means the door is open, the machine can't run. As soon as we close the door, this light comes off, right? We run the belt at full speed. Again, we run at 5 feet a minute for the conveyor, through feed. And we will see what this does for the top side with we are about 0.5 millimeter into the conveyor belt right now, which is not bad. This will not be a lot of conveyor belt wear at all. But I just want to be ultra conservative with the ceramic block on the PVC coating. Yours is a laser grade, which means it has a high tack, and it's rookie that we want to do a little bit more. So here you see the part coming out, and I'm feeling the edge. The edge is gone, but your grade is very good. So this was 5 feet a minute. Yeah, so I'll write down the setting, which doesn't mean anything because it depends on how long the blocks are, right? So the set point was 46.8, which equals a medium to light, right, from the pressure point setting. And then our feed rate was, so we ran this at 5 feet a minute. All we are going to do now is we're not going to change the pressure setting, but we can do a little bit more. We're just going to slow it down. We don't want to change the pressure setting because we don't want to go too much heavier into the belt. So we're just going to go to 4 feet a minute here and go with that. And then we're going to do 3 feet a minute and 2 feet a minute. At that rate, we're still going to have plenty of throughput, and then you can judge which kind of edge condition is good enough for what it is that you want to do. Is I'm comparing it to this. This is nice and round. This is also round. Nobody will cut themselves, and of course it's going to get better. Notice we have a little bit more temperature in the part. The PVC is not peeling. Very good PVC coverage. I'm afraid on the black stuff that may not be quite as good. And I can feel, you can't really see it on the video on the coated side, maybe a little bit here. We have pretty good edge rounding. So now we will just go down to 3 feet a minute. And then you'll start seeing a difference. On the black coating, we can increase the pressure a little bit because the material is thicker, so we could come down another 0.5 millimeter for a higher feed rate. So here at 3 feet, I think that is where you are looking to be with that edge. Perfectly safe, but at the same time, still no. And just to prove the point, so obviously none of these settings have changed. So that was 4 feet per minute. And this was 3 feet per minute. And then this one, we're going to make 2 feet per minute, which is going to be very slow. And of course you can fill the table. So on part of this side, we could put, look at this, we could put 1, 2, 3, 4, 5, 6 on a 44-inch machine, or about 9 of them on a 64-inch machine, 8 to 9 on a 64-inch machine. At 3 feet a minute, this is about 12 inches, you will have, so if you go with a 64-inch machine, you would have 9 times 3 is 27 per minute, times 60, about 1,600 parts per hour, one side. At 2 feet per minute, obviously, it would be 1,600, it would be more like 1,200, 1,100. So, here you see, now you're really getting some radius here on those edges. So this is 2 feet. So, on these here, we're going to go exactly the other way, and you can see already the way they were shipped, they are missing some of this. That of course can be an issue, so that's why where I meant the PVC on those isn't necessarily as good, but we have 5 pieces here, so maybe I'll leave this one out for right now, and we go straight to this one. All we need to do is change the material thickness. I'll show you how quick that goes. So, we are there. That's all there is to the material thickness. So, now at 2 feet a minute, like I say, now I can add another 0.5 millimeter to this, which I will do, right? And I will right away go 3 feet a minute. See what that does. So I'm a little curious with this black surface, whether it should have the same adhesion because it's also a layer than a fiber, but it seems to be somehow, maybe in your process, because it's heavier material, more compromised up front where you have some shears in it. So here it comes. Of course the surface is dull, it's scrubbing over it, but that doesn't use any abrasive. So you see we have a very nice surface here. I think you would be very pleased with this. So this is 3 feet a minute. I hope the black marker goes on here. 3 feet per minute. And the pressure was 46.3, which is more like medium. We have a little bit more temperature in the part. Right? So, and now what we can do is we can even go up another 3/10, but at the same time we go to 4 feet a minute. And the numbers don't mean anything really. It's just how long the brush currently is. It's always relatively. You find a point where you see where you are, and then you can go a couple of tenths up and down for more or less pressure. So, this is also a very good result. So this was 4 feet a minute, and 46.0 in terms of pressure. Right? So you see we are 0.8 of a millimeter more into the material than we were on the back side. So, I'm going to do is I'm going to use that 4.6 on this part here. See, this has very good intact. You have some spots open in the middle, not up. I'm going to go back to 3 feet a minute with the higher pressure, just so that you see what that is. And then the last two, we're going to run at 5 feet a minute. And I can show you how you can stack them on the machine in what kind of phase. When you wait for a single part, it just takes a long time. But small parts like this, if you were loading them consistently, you would be busy loading even at low speed rates. So here you see now we start to have a little bit more black space around, but still not bad. This was 3 feet per minute at 46.0 medium plus pressure. Very good. So, now, and that may be totally insufficient. Now we're going to take those two, we're simply going to run them at 5 feet a minute. And like I say, in production setting, you would want to space them about like this, an inch apart, so that the brush can recover and hit that edge as it comes off the other part. Have a part that already was peeled a little bit more. If you would take this part and run it perfectly parallel, then you wouldn't have a cross edge here. Then you would have the grain going parallel. That's always a choice. So that's 5 feet per minute, 46.0. And now what I will do is I will take this. You'll see that only after you take the crosshatch out. We're just going to run this perfectly parallel because it's going to regrain the part in the direction of the grain. So, the machine is set to 2.5 millimeter material thickness. I will show you how you set the brush height. On the other side, you probably want to be about 4 millimeter into the material, 3-4 millimeter into the material. So here's this. So this is basically 2 passes. 2 pass, 5 feet per minute. One was, first pass was this way, and the second pass was this way. We could have done that right away. We could have done the first pass already this way, which helps you if it's open like that. So now we take this part. We're going to go back. Being conservative, just 2 feet a minute, because we're trying to eliminate these little hooks here on the end, right? We have the machine set for the correct material thickness. So, and I'm going to turn this brush speed down, because what that allows me, I can now hear when I start hitting the conveyor belt. About right here. Okay, 46.2. I'm in the conveyor belt. I want at least a millimeter more, so I go half a crank. I'm at 45.2 right now. 1 millimeter in the conveyor belt is a little bit of wear, but not very much wear. If you were 2 or 3 millimeter in the conveyor belt, that would be different. So now we go back to maximum speed, and we go. So this is a really nasty spike here on the end. So I remind you, only 2 feet per minute, and we'll see what that does. If that makes a real good result already, then we can go faster. And of course the consistency is really good, and you never have to worry about a secondary burn in this product. Other edges, not on the corner, are going to be really, really nice. You can already see the white line as it goes around the part. That's your edge rounding, right? And the marks at the end are completely gone. So no issues here at all. You will love that part. So that is 2 feet per minute, right? At 45.2 plus pressure. So it's a high pressure. So, next part we're going to run exactly the same way, but we're going to run it parallel so that you can see what that looks on the screen. And then we're going to go a little bit faster and a little bit faster, and you can determine at what point you don't like the results anymore. There may be, I'm pretty sure that there will be a couple of parts where you say, well, this isn't good enough. Sure enough, then you need to go slow. See what that surface looks like now? Now we are parallel to the grain, we don't have a cross edge. Of course, what we don't do is we don't eliminate the scratches. So that was 2 feet per minute. We have good temperature in the part. It's not hot, but it's nice and warm. Cold days like this, pleasant. 2 feet a minute, and we were running parallel to the grain. There you go. And again, the corners are impeccable. They are really nice. I think you'd be very pleased with them. So, now we're going to speed up. No speed setting. We go to 3 feet a minute. And you could have nuances in there. You could take 2.5 feet a minute or 3 feet. It just happens to be so that on our potentiometer, it goes from 1 to 10, and the machine runs about 1 foot per minute faster than the number on the potentiometer. So if you set it to 1, it's about 2 feet, 2 or 3 feet, and so forth. So at the end, it's more like equal, 10 feet per minute. So once you get past 5, it starts to go to the number. The number isn't supposed to mean anything. It's simply there because potentiometers have a scale of 1 to 10. So if I look at this is 3 feet per minute. I think that is still fully sufficient. I think you'd still be happy with that. That is 3 feet per minute. And again, at 45.2 plus pressure. Okay, so let's go to 4 feet. Beyond 4 feet, what I would do is I would actually reduce the pressure in order to make it gentler on the conveyor belt. Right now, the way this is running, the conveyor belt would be between $1 and $2 of consumable per hour, where the brushes in material like this are about $3, maybe $4 consumable per hour. So the total consumable per hour would still be below $6 per hour. So 4 feet, I think that still looks very good too. So we will go to test this because for the thinner material this will be better. We will now go to back 46.2 full millimeter up. This is the part with the writing on it, and this is 4 feet per minute. Let's not forget that. fairly quick. You see how quick I can change the settings on the machine. The hand wheel is far quicker than walking up to a screen and punching in numbers and stuff like that. So here I feel a little bit something. Yeah, that's still a little bit gnarly. That was exactly what I was trying to do, so that you can see basically where the limits of the process are. Actually, 3 of them feel okay, not great. This one still has a little bit something. So I'm just going to mark that one. Okay, so this was 4 feet per minute. And the pressure was again 46.2 medium. And the result, of course, here is questionable. So, back to this. Now we're going to be more in the conveyor belt again. So I'm going to have to slow this down. I'm going to start at 2 feet a minute again, because I need to bring thickness down, so I'm going to be a little bit heavier. Now I'm again into the conveyor belt as hard as I was in the beginning when I ran these parts. I came up with the brushes by 1 millimeter. I came down with the material thickness by 1 millimeter. So overall my brushes relative to the conveyor belt are exactly in the same position in both. But the pressure is still medium, because the overall pressure on the surface of the part, of course, is only 46.2, it's only medium. But in thinner material, you have to reduce that pressure a little bit, and this is also a big reason why we are going slower. So your thicker parts can potentially run faster than your thinner parts, unless you're willing to sacrifice a higher consumable in your conveyor belt. And that looks very good, feels great. You can see the right line again on the part coming out. So that is alright as it goes, 2 feet per minute. Right? And a 46.2 right. I think that's still a very pleasant for that part. So, actually I should have run the 2 feet on that part. I ran it on the 5 feet. We're not going to run this at 5 feet. So I'm just going to run this at 2 feet again. And this time, maybe we're just going to run it parallel. And then we're going to run this at 3 feet. See how it comes out. Then if that doesn't come out, we're going to do something different here. This way you have the whole variation of the process, which is, you see, we didn't need a part for setup or anything like that. I kind of did that with the part that I used from our own inventory for the film, to make sure that we don't totally rip into the film too hard. But you really don't need a first part or anything like that. If anything, it could be that you need a rerun the first part. That would be it. So at 2 feet a minute, obviously it takes a little while for the part to come out. There it goes. So you can see what that looks like if we have perfectly parallel parts. Minute and 46.2, and we are running parallel. Now with your long part, you obviously can't do that. You can only go as wide as the machine is, but you see this is an extremely nice surface. We have a little bit left here. It's not enough for yourself to cut yourself, but you still see it. That's basically on your sample that you gave me too. You can see it still. It's there. But it's obviously so that you can't cut yourself. So this condition is about the same as this condition here. And that's, of course, going to get worse when we go to 3 feet. Again, in the thicker material, we can apply more pressure. That's why higher feed rates would be possible. In the thinner materials, you may be restricted to 2.5. The last one, I think I'll run at 2.5 feet a minute so that you can see what that difference is as well. Because it doesn't make any, in my opinion, it doesn't make any sense to go faster than 3 feet per minute. And of course, it always depends on how much burr you really have. If you tighten your die clearance a little bit on your thinner material, it could be that you can run faster also. These edges, like I say, this one has a little bit something, this one is very good. This one has a little bit something, this one has a little bit something. So I don't know if I would like to see the difference. Right? And you see the difference in the surface between the crosshatch and the parallel. So this one, like I say, I'll go and run at 2.5. And I'm going to go a little bit more. You know what? I'm going to go maybe total crosshatch. See what that does for the edge. Should also be enough. The longer parts are going to be almost parallel anyway in the machine because you only have the width of the machine on the 64-inch machine a little bit more than on the 44-inch. You can see it, but it's not sharp. Right? Nobody's gonna bleed. So that was 2.5 feet per minute. That's 46, which is kind of medium. All right, and that concludes our test for you. I will send those cards back today. I will put them in UPS for you. And then we have a conversation once you have it. Thank you very much.